Picture this. It is midnight. Your laptop fans are humming and a brand new repo is sitting on your desk. You hit one command, close the lid, and go to bed. While you sleep, an AI coding agent works nonstop for 24 hours trying to build a full clone of Claude.ai, the real production web app. No human hands on the keyboard, no coffee, no breaks. Just an automated junior dev team in a box. When you wake up, the question is simple. Did it actually ship something real, or did it collapse into chaos? Anthropic and engineer Cole Medin decided to run exactly this stunt. Wire Claude into an open source harness and let it code for a full day, aiming to recreate the Claude.ai interface from scratch. Not a toy chat box, but projects, conversations, artifacts, file uploads, the whole thing. On YouTube, it looks like a spectacle. But under the hood, it is a serious test of whether modern coding models can act less like autocomplete and more like a tireless, organized dev team. In a minute, we will see why this experiment quietly changes how you might start your next app. Most long-running AI coding attempts fail in boring ways. After a few hours, the model forgets earlier decisions, loses the thread of the architecture, and starts hallucinating files or declaring the project done while half the features only exist in the prompt. Context windows fill up and humans have to babysit every major refactor. Anthropic's harness attacks that exact failure mode by doing something surprisingly old school. It moves memory out of the model and onto disk, Git, and structured files. Here is the twist nobody talks about. Stamina, not raw intelligence, is the real bottleneck for agent coders. Instead of one giant 24-hour mega chat, the harness runs many short, focused sprints. It coordinates multiple Claude code style sessions, each with a narrow goal, like add this component or make this test pass. It tracks files, tasks, and test results in separate context windows and persists everything to disk. Every new agent session starts with a distilled snapshot of what matters, not a messy transcript of everything that came before. The result is an AI system that behaves less like a forgetful assistant and more like a deterministic build pipeline that just keeps going. So what was the actual mission? Build a Claude.ai style web app clone, end-to-end, with zero human edits once the run began. That means real conversation history, sidebar threads, project switching, artifacts, and genuine file uploads that flow into the model and back out as references in the UI. On top of that, it had to deliver a clean, responsive front end that feels like a modern SaaS product, not a student project. This is exactly the kind of dense, full-stack work that usually takes a human team days just to scaffold. If an unattended agent can even get close in 24 hours, that changes who gets to build software next. The harness starts with an architect of sorts called the initializer agent. This agent never writes real features. Instead, it reads the product spec, like a pseudo PRD for the Claude clone, and explodes it into a machine-readable blueprint. It produces 4 key artifacts, a massive feature list in JSON with over 200 granular test cases, an initialization script, full stack scaffolding, and a fresh Git repo. No ego, no shortcuts, just careful upfront planning that the later coding agents will follow for hours. That feature list JSON is the secret weapon. It turns vague ideas like support projects and conversations into hundreds of tiny testable behaviors. Start a new chat, upload multiple files, render artifacts, handle empty states, switch projects correctly. Each behavior becomes a test case with a description, files touched, and acceptance criteria. This is AI native test-driven development. The system knows exactly what done looks like before a single feature is implemented. In a moment, you will see how this rigid checklist becomes the heartbeat of the entire coding loop. The initialization script is the glue that future agents rely on. It bakes in decisions like framework choice, package manager, database bootstraps, and dev commands, so no later session wastes tokens reinventing setup. Scaffolding then lays out directories for front-end, back-end, API routes, and shared utilities, plus placeholder files that hint at routing and state management. And from line 1, everything lives in Git with version history ready for commits, diffs, and rollbacks. Without that history, a 24-hour run would be one bad refactor away from total collapse. Once the blueprint is in place, the real grind begins with the coding agent. This agent wakes up in a fresh context window, reads the current project state, and picks the next feature to attack from the progress file. Every loop starts by running the full regression test suite, catching any regressions before adding new code. Only when everything that used to work still works does it implement a new feature, edit files, rerun tests, and if it succeeds, commit to Git and update progress. There is no chatting and no brainstorming, just a relentless march toward green tests. Here is where the stamina problem finally gets solved. When a context window starts to clog with too much history, the harness simply ends that session and starts a new one. The next coding agent instance does not reread a 20-hour transcript. It reads the codebase on disk, the structured feature list, the test logs, and a compact progress file. In other words, memory lives outside the model. That is why this setup can keep coding for a full day without drifting completely off spec. Another subtle but important choice. This entire experiment skips the command line interface. Instead of a human typing Claude code into a terminal, the harness talks directly to Claude through the Python Agent Software Development Kit. The Python process spins up agents, streams tool calls, reads and writes files, and even restarts sessions when they stall all through code. That means model choice becomes just a config line. You could swap in a cheaper Claude Sonnet for most iterations, then switch to a heavier Opus-style model for gnarly refactors, or even plug in third-party coders that speak the same protocol. This is why software development kits, not simple tools, look like the real future of agentic coding. Command line tools are great for one-off fixes or interactive debugging, but they fall apart when you need long-running jobs, persistent state, metrics, and security controls. A harness built on an SDK can log everything, enforce budgets, restart agents, and coordinate multiple workers like a microservice. In practice, that means you can treat autonomous coding as an internal platform, not just a fancy autocomplete. And that platform can quietly build prototypes, user interface shells, and minimum viable products while you work on strategy. So how do you actually run something like this yourself? Anthropic has open-sourced an autonomous coding quick start on GitHub. You clone the repo, install dependencies like Python and Node, run npm or pnpm install, and drop your Claude credentials into an environment file. The harness ships with example configs for the Claude.ai clone, so you mostly tweak instead of invent. With a bit of setup, you can point the same system at your own spec and watch it grind through features while you are away from the keyboard. The non-obvious killer feature is cost control. Cole Medin points out that you can use a Claude subscription token, the same one your browser uses for Claude Code, instead of racking up huge metered API bills. That makes 24-hour experiments far more accessible to solo devs and small teams. Suddenly, running an overnight agent to scaffold a new SaaS app is not just for big companies with massive budgets. It becomes something you, personally, could try on a weekend. Zoom out, and the stakes are bigger than one Claude clone. If a harness plus a capable model can really build a production adjacent web app unattended, the meaning of start a new project changes. Instead of spending the first week wiring auth, routing, and basic UI, you write a spec, hit run, and come back to a working skeleton. Human developers shift from manual scaffolding to reviewing, hardening, and adding the weird product-specific details. The first draft of your app might soon be written by a machine that never sleeps. That has real consequences for jobs and teams. Junior developers may spend less time wiring boilerplate and more time on design, debugging, and product thinking. Small startups could launch richer products with tiny headcounts. Even big companies might spin up background agents to prototype features before a single sprint planning meeting. The question is no longer can an AI help you code, but how much of the boring setup you still want humans doing at all. Of course, today's systems are not magic. They still need solid specs, good tests, and human review before anything touches real users. The 24-hour Claude run is a glimpse, not a finished factory. But it proves something important. With the right harness, models are already capable of sustained, structured work that looks a lot like what junior dev teams do. The gap between research blog diagrams and real, unattended builds is closing faster than most people realize. So where does this go next? Imagine long-running AI agents that quietly build minimum viable products, internal tools, and user interface shells overnight, triggered by a ticket or a product spec. Imagine your codebase always having a background worker fixing flaky tests and updating dependencies. This is less about replacing developers and more about surrounding them with autonomous coworkers that handle the grind. The teams that learn to orchestrate these agents instead of competing with them will ship faster than anyone else. If you want to see more deep dives into real AI coding experiments and what they mean for your job, hit subscribe so you do not miss the next breakdown. Drop a comment and tell me this. If you had a 24-hour autonomous coder at your disposal,